All right. Hey, folks. It's always fun to have an opportunity to talk to a community like this. So thanks for joining us. Today, I'd like to give a brief introduction to a technology that we've been working on for a little while. It's a collaboration between Heptio, which is a little company that Joe Beda and myself started about 18 months ago, and Yahoo Japan Heptio. And the intent here is to start really bringing these worlds together. So let's just jump in. So the first thing I wanted to say is, you've probably all heard the words cloud native. It seems to be almost hit that sort of crescendo of buzzword awesomeness where everyone's talking about cloud native. I think one of the most common misconceptions about cloud native is the idea that cloud native applications are applications that you build to run in the cloud. And when I say run in the cloud, I mean on Amazon or Google or Azure. That's really not the way I tend to think about cloud native. For me, cloud native is about borrowing a lot of the patterns and practices that were pioneered by the internet giants to solve problems at scale. And those patterns and practices apply just as well to the problems that enterprises face on a day-to-day basis. In many cases, enterprises are starting to tackle the challenges associated with internet scale applications as most modern businesses become more intrinsically connected to their consumers through web and mobile properties. As they start really chewing on problems around IoT and increasingly connected devices, those same set of problems exist. But they also exist in terms of the massive heterogeneity of the workloads that enterprises run. And so technologies like Kubernetes and containers have really brought that to the fore and made a new way of operating accessible to organizations of all types and sizes. Now, one of the key challenges that we face is that cloud native doesn't exist in isolation. As you start thinking about what we built with technologies like Kubernetes, the idea there was to really start providing a framework where you could profit from these capabilities, but you could do it anywhere. And one of the beautiful things about the emerging cloud native technologies, things like Kubernetes and Docker and all of the adjacent technologies, is that they work well kind of everywhere. You can run them in your own data center, you can run them at the network edge, you can run them in the public cloud, and they create this incredibly consistent environment to run your applications, and they do it really, really well. I'm sure you're all pretty familiar with Kubernetes by this point, so I don't need to go digging into that. Now, one of the interesting challenges is how do we merge these streams? The reality is greenfield doesn't exist in most organizations. Technologies like hypervisor-based workloads aren't going away. And so it's up to us, the community, to start thinking about what set of assets can we create, what set of technologies can we bring to bear that bring these worlds together and that solve some existing problems that have been there since day one. And so for me, this isn't about displacement. It's about augmentation. It's about creating ways that these technologies work intrinsically better together. And one of the standing problems that we see a lot is how do you deal with internet scale ingress, the ability to connect a myriad of devices or consumers or other things that are existing out there in the wild in the internet into a blended environment where you might have OpenStack, you might have Kubernetes, you might have a variety of technologies. And traditionally, the types of technologies you use for load balancing have been grounded in the old world. So there's a lot of investments that are made in big iron load balancing technologies. There's a lot of investments that have been made in software load balancing technologies. But by and large, these have really been designed around relatively traditional workloads. Cloud-native workloads have some interesting new properties. They're much more dynamic. They're much more robust in the face of failure. They scale much more rapidly to deal with the needs of modern enterprises. But being able to wire that in so that you can deal with the deluge of information that is emerging is challenging. And as we start thinking about this problem space, there's a lot of need to do more at the L7 level. So if you think about the way that a lot of load balancers have been set up, they tend to run, initially like L3, L4, and they leave a lot of value on the table in terms of application visibility and application level configurability. And again, because a lot of these workloads were built around relatively static configuration models, they don't translate very well to this new world. So the good news is there's a lot of technologies that are emerging that make it easier to deal with this, and we'll be talking about one of those today. So we're going to be introducing a new project, which, as I said, was a collaboration between Heptio, Yahoo Japan, and Heptio, which is a scale-out load balancing solution that's designed to work well in both of these worlds. So you can deploy it on-prem, you can deploy it in the cloud. It works well with Kubernetes and supports the intrinsic dynamicism of these cloud-native workloads. But it also solves some hard problems that exist in the traditional world of virtual machines, where OpenStack has gained a tremendous amount of momentum and traction. At the heart of it, what we've built is a cloud-native load balancer. And when I say cloud-native, I don't mean a load balancer for cloud-native applications. I mean a load balancing system that is designed itself as a cloud-native application. So this is a system that benefits from a lot of the properties that are emerging around cloud-native technologies. It's hosted in Kubernetes. It uses a broad portfolio of the cloud-native technologies that are starting to emerge. And as a result, it's easy to deploy, it's easy to manage, and it's easy to live with. So I'd like to hand off to our friends from Yahoo Japan, who will be talking a little bit more about this.
Hi, I'm Ryutaro from Yahoo Japan. Let me introduce about Yahoo Japan. Yahoo Japan is a joint venture between SoftBank and Yahoo Inc. Yahoo Inc. was bought by Verizon, but we are still independent. We run many services, for example, news, auction, weather. There are over 100 services. We have 72 billion page views per month and 10 data centers and 100,000 servers and over 50 OpenStack clusters. Most of our services run on OpenStack. Currently, we are migrating our application infrastructure to Kubernetes and Cloud Foundry from OpenStack. Let me explain why we need a software like a Gimbal. Many of our services use layer 4 balancing, so there is a lack of deploy speed. We can't deploy new function quickly enough. And if we found some problems on the deployed version, we can't roll it back speedily. And there is no layer 7 latency visualization. And so we are migrating our infrastructure from OpenStack to Kubernetes now, so we will use both of them for a while. To solve these problems, we need faster and multi-cluster service discovery for both OpenStack and Kubernetes, and canary deployment with instant rollback, observability, and performance. We want 60 gigabps and 3 million concurrency as the performance values. In order to meet these demands, Gimbal has been released in collaboration with Heptio. Why did we choose OSS instead of bespoke solution? Because we would like users with similar technical issues to collaborate together more effectively. It's also important with this kind of software to be able to easily cooperate with different products. By releasing on OSS, we believe we can deal with a wide range of backend products and easily maintain the code. We want to boost the Gimbal community and make Gimbal more user-friendly. Yahoo Japan will also contribute in various forms. Thank you.
In terms of the conceptual approach that we took to building out Gimbal, as I mentioned earlier, it was a lot easier than it ought to have been because we were building on this cloud-native baseline. We wanted to approach this from a minimalist perspective, create as little technology as we could. We wanted something that was cloud-native, but legacy-friendly. And we were also incredibly focused, not just on scaling the number of servers that were under management, but being able to scale the teams, creating a very natural environment where as organizations bring more and more infrastructure to bear, as they bring more applications to bear, as they bring more teams online to maintain them, it became a very natural environment to do that. And so we looked across the technology set, and obviously there were a lot of great technologies already available that we could wire together in a relatively minimalist way. Kubernetes for hosting, which I'm sure you're all familiar with. The Envoy proxy, which has done incredibly well in the community. It was invented or created by the Lyft folks and recently contributed to the Cloud Native Computing Foundation. And then Prometheus and Grafana for increased observability. And what this gave us is, at the end of the day, as I mentioned, a cloud-native environment for load balancing, extracting the load balancing function out of a discrete environment, standing it up in its own cluster, and providing a principled way to start partitioning this across teams and providing isolation of the discrete components. So at the heart of it, there's a few simple pieces that we've put together. The first is a set of discoverers. So these discoverers look inside an environment, and that could be a Kubernetes environment to discover the services and endpoints available, or it could be an OpenStack environment. Instead of services and endpoints, we think about load balancing groups and discrete nodes. And those are then propagated into a set of discrete namespaces so that the teams that are dealing with them have access to an environment that's tailored specifically to them and can be configured at the top level by an administrator. And then the system pushes all that down to Contour, which is a minimal Kubernetes ingress controller that Heptio previously contributed, and then wires it into a set of Envoy proxies that are deployed as a daemon set on each of the nodes. And bringing it all together gives us a system that has some really great properties. There's a common point of control. There's a simple, robust environment where it can run. It's easy to add additional nodes. And most importantly, it's cheap. It scales well, and it's incredibly powerful. As we look to the future, we're still in the very early days. I'm a huge believer in delivering technology or building technology, designing technology in the open, which I think is very consistent with the OpenStack values. And with the Gimbal technology, what we released is an early version. We consider it an alpha. And what that gives you is a basic OpenStack and Kubernetes discoverer components so that you can start running these technologies together. It gives you simple ingress routing. It gives you basic observability. And it's obviously documented. And then as we look to the future, we're going to continue to evolve this. We're going to add multi-team policy enforcement so that each of those namespaces can be assigned to a team. It uses the Kubernetes role-based access control system, so we didn't have to reinvent the wheel. It all ties together very nicely with the Kubernetes toolchain. And over time, we're going to look at a lot of other features. But most importantly, we're going to look to the community to help define and drive this. So if you want to take a look, it's all out there in the open. We invite you to check out the Gimbal project on GitHub. And we look forward to hearing from you, getting feedback. And if you're up for it, push some PRs to us, file some issues. And we'd love to hear from you. Thank you for your time.